Hello, this is a lesson on rational expressions, more specifically the domain and some basic operations on rational expressions. So first let's talk about what a rational expression is, and it's essentially a fraction where both the numerator and denominator are polynomials. So you can see example that I have here is a rational expression. Something that might look like a rational expression but technically is not would be something like this, where because of the root x, the numerator is not a polynomial. So this would not be a rational expression. So looking at these two, think about why the value for x cannot be 1. So I want you to pause for a second and answer those, and then resume the video. In the first one, we would get a negative inside the radical. And for the second one, we would get a denominator of 0. So in each case, those would be undefined. So what we mean when we say domain is basically the possible values for the variable that make the expression defined. And so a lot of times to find the domain, we think about what values will make the expression undefined, like what values can it not be, and then the domain is everything else. So for each of the expressions above, in the first one, we want to make sure that x minus 3 is greater than or equal to 0. That will avoid a negative in the radical. So in this case, we're actually finding what the domain can be right from the start, and it's basically anything greater than or equal to 3. In the other one, we want to make sure we avoid a 0 in the denominator. So we're going to find out what values give us a 0 down there. So if x is negative 4 or 1, that denominator would be 0. So we say that the domain is everything except x is negative 4 or negative 1. So we say that x cannot be negative 4 and 1. So here's one to find the domain of. And notice you have a fraction within a fraction. So the first thing we notice is that x cannot be 2, because that would make the top fraction undefined. X cannot be 4, because that would make the bottom fraction undefined. And then if we consider the entire fraction as a whole, we see that x cannot be 3, because that would make the denominator 0, right? If x is 3, then that bottom fraction is a 0, and therefore our denominator would be 0. So the domain is everything except 2, 3, and 4. Now let's get into some operations, right? So we're going to perform the operation and simplify. In this case, it's sort of dividing two polynomials, so this is a rational expression, and the only thing we can do is simplify it. So what we're going to do is factor the top, factor the bottom, and cancel any common factors. So x plus 2 over x plus 1 is the simplified version. Same thing here, we're going to factor out a 2, factor the denominator. Now x minus 4 and 4 minus x are not exactly the same factor, but they are opposites. So I can cancel them and leave behind a negative. So negative 2 over x plus 3. You could have also left the negative in the bottom instead, in which case you would have gotten a positive 2 over negative x minus 3. Either of these two is acceptable. Number 5 is a multiplication problem. So again, we factor. And we cancel anything in the numerator that is also in the denominator. So these x minus 1s will go. Everything else stays. So this doesn't look very simplified, but this is the simplified form. There you go. Number 6 is a division problem. We treat it like a multiplication problem. The only difference is we're going to flip and multiply. So I factor as I had before. Now I'm going to multiply, so the numerator is going to go down to the denominator. And I factor it. And then we've got sum of cubes. And now I cancel. So I can cancel x minus 3 and 3 minus x, knowing that I need to leave behind a negative 1. And I can cancel the x plus 3's. And now I just multiply across. So negative x squared plus 3x minus 9 over 3 plus x times x plus 4. Number 7 is an addition problem. And since we're adding fractions, we need a common denominator. In order to find a common denominator, we first factor. So the least common denominator is x minus 1, and x plus 1 squared. So now I take one fraction at a time and just convert them. So what I need in the first fraction is an x plus 1 squared. And what I need in the second fraction is an x and an x minus 1 times the x plus 4 that's already there. And then all of that will be over the LCD. So now I just simplify the numerator. So if I know what x plus 1 squared is, and then I multiply by the 3, we get this. And then x squared minus x times x plus 4 is going to be x cubed plus 4x squared minus x squared minus 4x. Let me just double check that. All right, we're all good. So now let's just combine like terms. So we end up with 7x squared and x cubed and where my x is, plus 2x plus 3, and now we write in the LCD, which was x minus 1. So in your final answer, make sure you write the actual LCD, but you can just use the letters LCD along the way. Subtraction, very similar to addition. We need an LCD, so x minus 2. And I know that this is a difference of squares, and I already have an x minus 2 in the denominator of my other fraction, so I would like to get an x minus 2 here. So what I've essentially done is multiplied the denominator here by a negative 1, so I have to multiply the numerator by a negative 1, which is just easily done by making that a plus sign. So now the LCD is x minus 2, x plus 2. And so this fraction needs an x plus 2. This fraction needs an x all over LCD. So we get 2x plus 2 over x minus 2, x plus 2. Now I could factor the numerator, but since it's not going to cancel with anything in the denominator, I'm just going to leave it as is.